Hi everyone, this is Xbyte and we are introducing network telemetry across all of us. So this is a deep session and we are going to go deep inside network observability. So what I thought to start with network telemetry, since you know that network has been growing and network has been grown already in the data center, ISPs and the hyperscaler, right? And it is very tough to manage all the big network with the current CLIs and the current tools, right? And since the services are very critical, like we have AI observabilities and all of the data are on the cloud, right? So this basically we there are so many issues to checks and verify the real-time data in the network, right? What is happening in the devices across the network from point A to point B. So we need something not like a legacy, like SNMPs, which can poll our network events periodically, but we need something who can fetch the data from the device or from the stream. It just create a stream of data from the network and just give us output and the dashboarding so that we can do a check from our sides and we can just take a right steps in order to mitigate the network issues. So it is not just about issues, it's all about the analytics as well, like how the networks look like. Is it okay to grow further or what all use cases can be deployed in this network, right? So that's the reason we are coming with the network telemetry protocol here. And when we see, uh, I'll just move to the next slide. We'll go over the details. So before starting this session, I would like to introduce and this is a very basic session of network telemetry. So we are just introducing what this protocol is and why we need this protocol. And from a network engineer point of view, there will be a coming session and you would have a follow-up question as well, right? And in this session, basically, we are just going to speak about the what protocols we are being used in our telemetry and what is telemetry, right? And in the upcoming session, basically, we will be going deep dive into the protocols, like what protocols helps to bring the telemetry ups and how do we configure. We will do the lab, right? And based on the inputs coming from you all, I will be just putting it across the slides. Okay, uh, so moving forward, so basically this is the evolution of network monitoring, right? So because currently we have a reactive polling, right? So if something goes wrong in the network, so one of the MIPs, one of the agents sitting inside the devices, just take the data periodically and send it across the tools so that tools can verify the data and it can take creative actions for us, right? So, but now the thing is, if you see, all of the data are on the clouds or in the DCs, right? And we are going through the real-time data, right? Like the calls, VoIPs, AI, modeling, hospitals, everything is on the clouds, right? So, mm, so in that case, basically, if you think about that point of view from the customer's point of view, right? So even a single seconds of delay is not something they can afford, right? So if even the single seconds of packet goes drop and we don't see that in the tools, right? So that packets carries what data, we are not aware about that, right? Maybe that packet carries one of the voice call, right? Which is emergency call, right? And that get drops. And we are not able to see that in the tools that what is happening in the network, right? So that will create a big issues. So aligning with the current requirement of the world, right? Network should be more and more scalable. Network is more and more scalable, and it should be more and more manageable as well, right? So from the management point of view, how do we monitor the network? How do we do analytics? And how can we forecast a network for the further growth, right? This telemetry is required there. So from moving from the reactive pollings to proactive streaming of the network data, right? So that's where telemetry comes in the picture. So if we see the current legacy protocols, what we use in the devices, right, so regardless of any of the vendors, Juniper, Nokia, Cisco's, Aristas, etc., right? So when we think about the management protocols, so what we have today is SNMP protocol, right? So what it does basically, it polls the network events at particular interval, which we define, which engineer defines the devices, right? I want to poll this data after every 10 seconds or 30 seconds, right? So this is what is happening. This is the first thing, right? So it's a pull model, right? And it happens between some intervals, right? And if something goes wrong in that particular intervals, if there is any anomalies or microburst happened in that particular intervals, like from 0 to 10 and 10 to 20, right? So that will be missed, and we will never be aware what is happening in the background, right? Unless customer reports us, right? And that will give us a challenge to do a troubleshooting as well, because what we will see in the data, in the charts, right? We will see that everything looks good, right? But the customer live data point of view, live network point of view, right? They will still be dropping the packets, right? They will still have glitch in the network, in the services, basically from the service layer point of view, if you think about. So that's the problem of SNMPs, right? And we run multiple MIBs of SNMPs in the network, right? And that all MIBs pull the data, right? Just get the data from the devices, and which is getting pulled from the collectors, SNMP servers, right? So that adds a overhead as well on the CPUs of the devices. So that's a limitation. Second thing is that this is the events point of view, right? So if you are a network engineer, right, you know that there are two different aspects of networking and the network management and the protocols. That is control plane, data plane, right? Control plane, we know that, right? We don't play on that now. We work on data plane because data plane carries actual traffic, right? So how do we manage that? How do we monitor that? So we have another protocol that is IPFix. We also call it NetFlow, right? And basically it just take a samples of flow after every few intervals, right? And that sample is being sent towards the IPFix server, and that server will have visibilities, and that it does all the things from there, right? But again, that has delays, right? It samples the data from the interface. It will send that data towards the IPFix servers, and IPFix servers will just do all the modeling at their side. Then, on the based on their IPFix data, they take a decision. And what decision is that? So mostly when you look into data center or cloud provider, right? So they have their own DDoS mitigation mechanism, right? And certainly, how do they how do they identify that DDoS is happening, right? There should be some data point, right? So some of them uses the IPFix. They just collect the data from the interfaces, right? And then they see the behaviors of the sampling, right? And if they see any anomalies, right, or any single packet is hitting multiple times, right, or any single source is getting hit from multiple destination multiple times, right? So based on their analysis, they figure out that this is a kind of anomalies or DDoS, right? And they just block that traffic. So IPFix carries all this data like source IP, destination IP, source port, destination port, port number, right? And the index and the bandwidth, the traffic bandwidth, what each flow is taking, right? So it has all the details, right? So that's something about the data plane of the network, right? So that's really useful and helpful in current world, right? But again, since we are evolving every single day, right? We need something to be very realistic with real time, right? So there, if you think about streaming, right? So if you think about streaming, what is that? If something is going on that is being streamed live, right? So if the device sends data, live data to us, right? Stream that data to us, right? We will take an action immediately that what is happening in the network. So we can just slow down the anomalies. We can just slow down the effect of issues in the network or the event in the network, right? I'm not saying that we can just completely remove. This is network observability. We observe the network, what is happening, right? And based on that observation, we take an action, right? So if the observation is fast, right, the action would be fast, right? So if the observation is slow, let's suppose just to observe any of the anomalies, it is taking more than 25 seconds, right? So after effect, in 25 seconds, it will identify that something is going on. Then it will do analysis, right? Then 10 more seconds, right? Then it will trigger alarms that something happening in the network, right? Then again, it is more 5 more seconds, right? So 1 minute will go away, right? So in 1 minute, how many data is going to be dropped in the network and what that data carries, right? What that single packet carries in the payload, we do not know about that. So we have to fix that, right? So if we see from the root point of view, right? So the root is that how fast we can capture or we can identify the issues, right? The fix is normal. We know that how to fix the problem. We have so many engineers, so many tools, so many automation who can do a fix, right? But before fixing, we have to do identification, right? So just to make it speed up, right? So we need some sort of solution which can provide us real-time data, right, from the network, through which we can reduce the timing to identify the network anomalies, network events, right? And based on that events, we can take action to mitigate the problem, right? So that's another part of network management, right? So yeah, that's where we have telemetry. So basically, it sends us the nearby real-time data. I'm not saying it is exactly 100% very quick, right? But no, it's a nearby real-time data which we get from the telemetry agents sitting on the devices, right? So So when we see what is the differences between these two architectures, NMPs or IPFix or MDT, right? So or telemetry, right? So it all so there are multiple components, right? Which are involved to get this thing better, right? So if we see from telemetry point of view, I'll just go through all the slides and I'll just explain you. I'll just try to explain what is telemetry, right? Yeah. And since it is push model telemetry, right, it is more scalable, right? We don't have to worry about much CPU loads like we had in SNMPs, right, per MIBs, right? So that's helped us to grow, keep the device safe and healthy. Okay, so the thing is, if we look from MDT architecture, so what is MDT, right? So any of the protocols, any of the data transfer mechanism, right? They uses some kind of architecture, how the data would be encoded. So when we send data from the local devices to the remote servers, right, in which format it is going to encode it, right? And is that format very lengthy or it's as simple as it is, right? So from telemetry, right? So from telemetry point of view, basically we see that it supports MTT architecture, right? And this MTT architecture has a Yang model, right? So basically, so when we go to the RFC 6020 or RFC 7950, right, it is defined as RFC. So it's a model in which we write the data, right? How the data would be look like, and then how it would stream, right? So it uses Yang model. We will go through Yang model later on, the next chapter. But yeah, this is just the introduction. So I just want to introduce the telemetry in front of you, right? Then we will go through more and more deep dive. And then we have a gRPC. This is RPC, high performance RPC, and it is Google. It is developed by Google basically, right? And it is supported by multi-vendor because currently The network is multi-vendor network, right? Everybody wants to be a vendor agnostic, right? So we have all the vendors with us, including Sonic's Open Standard, right? So this is the protocol which supports all these vendors, including Open Standard, right? So, okay, so now the thing is, when we just go a little bit more deeper, right? So we see that, there are two aspects of data transfer, right? If the server pulls the data or the client push the data, right? It depends. So thing is, in in this architecture flow, right, we see that we have two different model, right? Push model and pull model, and both model has their own use cases, right? So the first one is known as dial out. Dial out is push model, right? So in this case is right. So when we say push, push means someone is sitting and pushing data towards towards somewhere, right? So who is someone? Maybe some agent, right? So where would be the agent resides? So the question is, who will send the data, right? So the data will be sent by devices, routers, switches, right? So agent has to be set in the data in the routers and switch itself, right? So it means that in the dial out model, right, the devices initiates the session, the limited sessions, right? And based on the local configuration, what we define, what we have to export to the servers, what we want to monitor, right? So based on that configuration, the devices pushes that data towards the server, right? And devices I mean is routers, switch, and firewall, any other devices, right? The second model is pull model. Pull model is basically dial in. It means I need in, it's an input, right? So the thing is, we have a collector, right? Collector means the servers who collects the data, right? And then it represents, it encodes, decodes the data, and then it represents, right? So collector initiates the session connection towards the devices, network devices, right? And then pull the data from the devices, right? So these are two different model of the telemetry. And when we go through more details, right? So, okay, before going into more and more details, right? We need to understand what are the core components of MDT, right? Because MDT is a big things, right? So, in order to deploy the telemetry or in order to make the telemetry work, right, there should be a core component, right, which works together to make the data transfer successful, right? So when we see here, right, so the first thing is that Yang model, right? Like I explained in the previous slide. So it's a standardized data model, right? And basically it defines the network states matrix, right? It is vendor neutral as well, right? So the thing is, let's think of that if we want to send any interface statistics, if we want to monitor any interface statistics, right? So we have to write that model that I want to monitor that particular interfaces on the devices or all the interfaces on the devices, right? And in that interfaces, to be very granular, right? What things I want to monitor? Maybe interface states, maybe interface errors, right? Maybe interface PPS or BPS traffic, right? Or maybe interface flap, right? So these are the parameters we want to monitor, right? So this should be defined. Somebody has to tell the devices that I want to monitor these all things, right? So there we have to write this in the Yang model, right? And like I mentioned that, okay, Yang model is open standard, right? So the template would be of maybe open config mode. Open config mode, basically it is written by the open standard. It is open standard, right? So anybody can write it, right? Develop it, right? And the another is the vendor native model, right? So it means that there are multiple vendors, and all these vendors has their own proprietary agents or kernels, or not kernels basically. I mean, some hardwares, right? They have their own, it's a vendor specific hardware, right? Which other vendor doesn't know, right? So they write their own um, vendor native config, right? How to export those data. Let's suppose that Cisco has RP, Juniper has routing processor, routing engine, right? And Juniper has then KRT, kernel routing table, and then Juniper has PFE, where the actual forwarding tables resides, right? So it has three tables, right? Control plane, then that copies into the KRTs, then that copies from KRTs to from that microkernel to PFAs, right? So they have their own architecture of the devices, right? They have their own RPDs, routing process daemon, routing protocol daemon, right? So all this device has their own daemons, which runs all the functionalities of the devices, right? And if we want to monitor all those things on the devices, right, then how would that work? It means that we cannot go with open standard. We cannot go with open config, right? Data model. We These vendors should have their own data model, right? Which other don't know. Okay, so that's basically a modeling part, right? The second thing is sensor. Okay, sensor is what? So if you have heard about SNMP's MIP, right? So what we want to monitor. So we configure SNMP. Let's suppose LLDP, we want to monitor LLDP, right? We want to monitor interface status. We want to monitor BGP status, OSPF status, right? So MIBs, right? The similar thing we have in telemetry, that is sensors. What is the data point we want to monitor? Is it interface counters, BGP states, etc., right? So this needs to be defined in the Yang model, right? And the thing is, this should be very specific, right? Let's suppose that I want to monitor the number of active prefixes in the BGP table, right? For that particular neighbors, right? So we can define that in that format in the Young model that I want to do that, right? Right? I want to monitor BGP adjacent rib in or local rib or adjacent rib out, right? So these are three different things, right? So you have to define this thing in the Yang model. What do you want to basically monitor, right? Okay, so these are sensors, right? And the next thing is subscription, right? So subscription is something basically now we know that what data we want to monitor, right? And we know that in which model we have to define those things, right? Now the thing is that in subscription we have to define the mode, right? Like what is the destination where I want to export those data, right? Stream that data, right? And what is the frequency? Okay, don't get confused about frequency here, right? Because frequency appears, it sounds like, it's polling after 10 seconds, 20 seconds. So yes, telemetry has that capabilities, right? If you want to monitor some data, right? Maybe on change, right? Some change happens in the devices, then it will send that it will stream the data towards the server, right? And if you want to monitor some data periodically, right? So you can also define that periodically. That is fine. And if you want to, uh, if you want to see the data just one time, let's suppose device came up, right? You want to check a snapshot. You want to take a snapshot of the devices of the device configuration, right? So you can do that as well. So we have all three aspects here, right? On stream as well, frequency as well, event triggers as well, right? So we have all these things. So we have to define that, right? So that's what I'm saying, that there are so many flexibilities in telemetry. How do you want to get to device observed, right? The thing is, now everything is ready. Yang model is ready, sensor is ready, subscription is ready. Now, how do you want to export that data, right? So if you are a network engineer, right? So we know that to transport any data from point A to point B, right? We need to have some protocols, right? Maybe layer 4, we have TCP, UDP, right? Layer 3, we have other protocols like PGPs, OSPF, size, right? So here also, there is protocol which helps us to export, transport those data towards the collector, right? So there it is, uh, gRPCs, netcon, restconf, and so when we see, okay, so we'll go through these protocols in the upcoming session, right? In the deep dive, that how this protocol works, gRPCs, netcons, or restconf, right? And then we have an encoder, right? So in order to export those data towards collector, right? So data should be encoded in some format, right? Let's suppose JSON, GBPs, right? So we also have to define that in which format we want to export data, or maybe in which format that particular device supports to export data, right? That also needs to be defined. Okay, so the last thing is that once everything is done, right, data is exported towards the collector, is streamed towards the collector, right? Then collector imports the data, right? It's an application or system, right? That receives and process the stream data, right? So you understood that, right? So that's the endpoint. We can just encode the decode the data and use it for any of the use cases. So I hope this is clear to everyone. If you have any doubt, any question, you can just mark the timestamp and just put it in the comment. I'll explain you. Okay, so the next one is the same thing, operational workflow, which I explained in the previous slide, right? That define data, then subscribe, then stream, then analyze, right? So it is just steps which is being happened, right? Okay, so Chuck, this is the most important part here in telemetry, right? Subscription mode. So like I said, subscription, right? You have to define how do you want to export the data, right? So basically there are three different modes of subscription here. Okay. So the first is once, which I said, this mode is designed basically for one time, right? Let's suppose you take a snapshot of the device, current states, current data, right? What are the, let's suppose before activities, you want to just take a snapshot. What are the status of interfaces? All interfaces are up, down, protocols wise, everything, right? So you can take it once, right? This is once mode. And yeah, it's basically works with both dial in and dial out steps setups, right? And the next one is Paul, right? Paul, it's basically very clear. It is anybody can understand what it's saying, right? So it has a periodic or on-demand retrieval, right? That I want to get that particular data on that particular interval, right? So we can define that for the monitoring. It's more of like sounds like SNMPs, yeah, yeah. Okay, it is used basically. It is supported by dial-in mode. Dial-in, that collector pulls the data, right? So basically, the collector initiates the connection towards a device GNMI server. Okay, so what is GNMI server, right? Like I said that there should be some agent in the devices, daemon in the devices who would be doing all this process, right? So that's basically that telemetry agent which needs to be configured or installed, right, on the devices through which your telemetry server talks. Okay, so the next one is stream. So stream is very powerful, right? So we know that we want to stream all those data. What is happening when the event triggered, right? So consist, uh, consistent. So basically, what is happening? Uh, any changes which happens on devices that should be streamed immediately towards the collector, right? So that we will come to know, we'll take action on that, right? That is streaming regularly, right? No stoppage. Yeah. So it could be event based as well, right? Something happens on changes. then it happens, or maybe regularly it is going towards the collector, yeah, some packets. Okay, so the next one is okay. So there are some sub modes of subscription, and one is sample, the second is on change, then targeted, defined. So when we think about sample, what is that, right? So it's a streaming at regular interval, right? I just want to stream that data into particular time period, right? And the second thing is on changes. On changes basically it's a push model, right, from device to uh, collector, right? So if anything happens on the devices, right, so it just with the help of that event triggered, right, it sends that data towards the collector. Then the third thing is targeted mode. So targeted basically it's on the devices basically what they want. They want to sample it or they want to do it on change basis, right? So there's something device chooses the best mode there, right? Based on the sensors. Yeah. Okay. Excuse me. Okay, the next one is protocol stacks of telemetry, right? So like you said, that telemetry is okay, it's the same thing which we have discussed, right? Data models, message, right? So between the collectors and the uh, devices, right, there must be some protocols running that I explained, right? And if protocol is there, there should be some capability to exchange between the servers and the devices, right? And with that capabilities, once they agree on that parameters, right, then it establishes the session between servers and devices, right? I'll go through it in the upcoming slide once I prepare a follow-up session on this, right? That how this all things works basically. This is important parts of telemetry in terms of troubleshooting the performance of telemetry itself, right? Because if you're running telemetry, so we have to ensure that telemetry is also working fine. It has optimal uses, right? It is reliable or not, right? Okay. Okay. So like I said, like the data modeling, right? This is the interesting aspect of telemetry, right? So the thing is, we have two different kind of models, right? The first one is open config models, which is vendor neutrals, right? The second one is I just gave an example of Juniper native model. So there could be other vendors native model as well. So it is available in GitHub. I'll share the link of that, right? So if it is Juniper specific monitoring, right, then you have to use Juniper native models. If it is generic monitoring, right, then you can use the open config model that time, right? So I'll go through the templates of this model as well in few slides, yeah. Okay, so path precision of the Yang model, right? So okay, this is very important part, right? So when we tell devices that what we want to monitor, I mean the sensor part, right? So we have to be very specific, right? So for example, because it totally relates to performance of the devices, right? So what happens if you just put the partial part, let's suppose interfaces, right? So interfaces has hundred of parameters, right, which we can monitor, right? Every single lines, right? So that's not a right way. Basically, we have to define like interfaces under interface. So we want to monitor states or counters or packets. Even though in packets, we want to monitor in packets or out packets to be very precise, right? So it helps us to reduce the overhead of monitoring, right? So that's what I said in the beginning. It is more scalable than SNMP because SNMP doesn't have this thing, right? So if you just want to monitor in packet, right? Input packet. So why would you put all the interfaces and take all the data to all the collectors, right? So that will add up more overhead. But if you just define it precisely, right? So the first thing is that your overhead will be reduced, right? The second thing is that the data transfer time will be reduced. The third thing is that the bandwidth which is being taken to transfer data from devices towards the collector will be reduced, right? And the data storing capacity also be optimized on server side. Okay, so the next one is that okay, yeah, unlike SNMPs, which basically we miss the micro burst or burst for that particular specific interval of time, right? So this doesn't happen in the telemetry. That's why the most use cases of the telemetry comes in the cloud environment, in the AI ops, the closed loop automation. It doesn't afford delay, right? The thing is delay. Nobody affords delay, right? Everything should be on time. So that's why we are here with telemetry. Okay, so that's all for today. If you have any question, you can just put in the comment. I'll try to explain as much as I can. And yeah, okay. So when we see the next coming session, right? So I'm just planning to have this topics covered in the next session. That is protocol and deep dive packets of the telemetries. Like we have a protocols, we have multiple codings, and I mean the data encodings, right? So I'll go through it. GNMIs, gRPCs, labbing. How do we establish session between devices towards the server? So I'll try to simulate the lab and I'll show you in front of you. And then use cases. Where do we need telemetry? That's the most important. You have the technologies, right? But if you don't know how to use that and where to use that, then it's completely useless, basically, I would say. So you have to know where do you want to use this technologies, right? So that's all from my side today. Thank you so much. And yeah, that's all from my side. Yeah.